Video number 6, we're going to run through a little bit smarter coding for stopping a robot when it's in a unsafe position. And we're going to be utilizing the digital ins and digital outputs for this scenario. So I'm just going to run through the program just to show what it's supposed to do. So you can see as it goes into the center, holds that position, moves out, and then it continues on. Holds position when it's in the center. So one or the other robot will always hold position inside the red box when the other robot is in the blue box area, or the area which the two robots can collide. Alright, so program is done. So let's run through the code. So just running through the code here, we have circle example number 1. I got rid of the blinking lights, so now we're going to be utilizing just digital in, digital out to do all the programming. We're doing a loop for 4 times, circular motion. This one is running at 70%, and I do believe the other robot's running at 40%. We have an argument stating that we are running, so argument register number 3 is set to 1, which means we're running. When it's set to 0, means it's not running. So when we set up the other programs, we have to look at this argument. Do we want to run it in the background, or do we want to run it as a code in parallel with our circle example? Because then we're going to utilize the argument to run that. So also with that, if we go to the cell, go to ins and outs interconnections, we have an input and output. So we set this up in previous videos. We have a digital 1 sending to digital input number 1 on robot controller number 2. So robot controller number 2 digital output will send to digital controller number 1 digital input number 1. So we're sending signals back and forth through the 1 slot and 2 slot. So digital out from one to go to the digital in to the other, and vice versa. So we're going to utilize the digital 1s to say that, hey, I'm in these red boxes. We're going to utilize digital 2 saying that, hey, I'm in this blue box, which means I'm in unsafe area. So let's start setting up a new line of code. So let's go to select, and I'm going to create, and let's go send over to robot. So I'm going to call that send over to robot. And then I'm going to go to detail. Now we're going to completely run this as logic. There's going to be no motion groups. So we're going to turn off the group mask from 1 to the asterisk so that we can run this parallel with our motion. So I'm going to go inside here. Let's go edit. And the first thing we're going to do is make sure that the digital outputs are off. So let's go new instruction, output, digital 1, and we're going to turn it off. And then new instruction, digital output number 2, and we're going to turn it off as well. Then I'm going to insert a bunch of lines of code, and we're going to continuously loop this over and over again. We're not going to run this as a background logic, so we're going to add a label number 1. And now what we need to do is we need to set up an if statement. If we are within this red box, and now we're not looking at depth-wise right now, we're looking at completely a 2-dimensional box. So when it goes into this box, we want to send a digital signal. So I went ahead and found these numbers. So it's the top left corner and the lower right corner. Top left corner, lower right corner. Now, right now we are working with robot number 2, so we're going to be utilizing these numbers. So this top corner for the Y component, which is left to right, is -174, and the Z component is 1500. The Y component for the bottom right corner is 477, and the Z component is going to be 900. Now, when we write the code, we have to write it as an if statement. If we're within these parameters, so the Y and the Z components, and we're going to utilize an AND parameter inside there as well. So let's go new instruction, if, and we're going to go if then, which gives us a lot more feasibility and maneuverability. And we're going to do this in multiple sets. So we're going to do the first corner, so we're going to add another parentheses, and we're going to do register number 11, which is the Y position, and we set this up in previous videos where we are position monitoring, and it's going to set to a register XYZ WPR. So we got the 11 position, and we're going to make that so that it's greater than equal to, so that means to the right. So right now we're working with the top left corner here, so we want to be greater than that, which is to the right. So we're going to insert, and let's switch over to greater than equal to, and that number was negative 174. So let's go constant, negative 174. And then we want the Z component, so we're going to insert, and we're going to do register 12, which is going to be the Z component, the Z position, and that needs to be less than and equal to that 1,500. So we're going to arrow over, and we're going to go less than equal to the constant of 1,500. So that's the one corner. So I'm going to end that parentheses now, and we're going to add another and. So now we're going to do the other corner. So we're going to add one more parenthesis here, and then we're going to go register 11 needs to be less than, so this is the Y component, so to the left, which is less than equal to the constant of 477, and register 12 needs to be greater than, because we need to be up, that constant 900. Now we need to add another parentheses so that the parentheses match. So basically what we're doing is that top left corner and then the lower right corner. So just kind of showing top left corner, negative 174, 1,500, lower right corner, 477, 900. We use the and, so we're including. So if any of those points are out, it will not go into this if statement. So then we have our then, and what we want to do is, if we are inside this box, we want to tell the other robot that we're inside that box. So we're going to go a digital output, number 1, which means we are in the box, and we're going to send that as on. So digital output number 1 is on. Then we also want to, if we're inside this box and the other robot is in the blue area, we want to hold inside this box. Okay, so we need to do 2 if statements. We need to do one if it's inside this blue box, we need to hold. If it's not within that blue box, then we can continue on our merry way. So that means we're going to have that hold off. So let's do the 2 if statements. So let's go new instruction, if, and this one we don't need the if then, we're going to just do if parentheses. So we're going to do if digital input number 2, that means the other robot is inside the blue area. So this is the condition we set up, or we're saying set up for that middle area. So if digital input number 2 is equal to on, which means it is in the middle area, equal to on, then we're going to over. So if digital input number 2 is on, arrow over, so we have the 3 dots, we're going to go ... equal to parentheses ... We're going to parameter name. So we use the MCR underscore GRP, which is group, machine group, bracket 1, dot, $symbol hold. So we have the parent and child portion of this. And in a previous video, video number 5, we went through how to actually find this, where it is in the BIOS, and also how to set this up. So if you did not get that previous video, check that out. It talks a little bit more about the machine group hold. Okay, so we're going to hold that position, and we're going to turn that as on. Okay, so now we need the scenario of, okay, what happens when we are not in that area? We don't want this robot to stop, even though that this one's not in there. So we need to do the other if statement. So we're going to do another if statement, parentheses, if our digital input number 2 is off, so is equal to off, then we're going to parameter name MCR underscore GRP, which is group, bracket 1, dot child hold. and we're going to have that as off. Okay, so it's not holding. So if this robot is in this blue area, while this robot's in the red area, this is going to hold, and it's going to come to a control hold, which means it's going to slow down to a point. So it's not going to immediately stop. Okay, so that's an emergency stop, which is not really good for the robot, so try not to do that. So we want to come to a slow hold position, which is why you will see it kind of come slow down to a point where it stops. If the robot is not in this blue area, like it's over here, then we're going to continue on. Now, if this robot is not in the red area, we want to send a digital output number 1 as an off. So we're going to do that as an else statement. So if that is within the red area, this is all going to happen. If it's not in the red area, that's what the else statement does. So we're going to go in the else statement, and we're going to go new instruction, digital output number 1, which means are we in the red? If we are not in the red, that means it's going to be off. Okay, so that's the else statement. Then we need to end this entire if, so we're going to go new instruction, if select, over, and we're going to go end if. Arrow down, and right now we have our end if, so we have our entire if statement. So let's add maybe 4 or 5 more lines. We want to loop over and over again. Now, because we're looping logic, which happens to take like milliseconds to actually happen, we don't want to continuously overload our CPU. So we're going to add a very minute wait in here. So we're going to wait maybe, 0.01 seconds or 0.05 seconds, something around there. So 0.02 seconds, we can check it out later, see if that's going to be a problem. So we're going to wait a minuscule amount so we're not eating up CPU time over and over and over again when this is looping. So this loops in milliseconds. And so then we're going to have a determination. Is the other robot or this robot moving? If it is, then we're going to jump back up to that label 1. If it's not, then we want to end the program. So we're going to go new instruction, and we're going to go if, and we're going to just do a normal if statement. So if register number 3, which is that argument, so is the movement on? That means it's 1. If it's 0, then it's off. So if it's equal to 1, we want to keep jumping up to label 1, which is at the beginning. If it's not, it'll continue on and then it'll end the program. So that argument comes from our circle program. So let's find that circle program. So circle example number 1. And here's that argument. So when it's on, so it goes through, UFrame, toolframe, override is 70%, register 3, which is the argument, sets as 1. Now when we go down here, it will go down all the way down to the bottom, in which we'll have our argument as 0. So at the end, you'll see register argument 0. So let's now call that program. Alright, I just had to reset the entire program here because things were going a little haywire. So let's just go into line number 6 and let's run that program in the background. So we're going to go new instruction, and we're going to go over. We want to run parallel tasking, so we're going to go multiple control, run. And we're going to run the send over robot. So send over robot. So that's the program we just created. So running that in the background. So now we also have to figure out, okay, are we in this position right here? Now this one we can monitor at all times if we want to. So we can run this as a background logic. Now, do we have to run it as a background logic? No, we don't have to run it as a background logic. Okay, we're going to just set it up a different way. So it just shows you the 2 ways of running a digital code. So running send over is running it parallel, and then in the background we can run it as well in processing, which over and over and over again. So let's just go select and let's create a new program, and let's call it in the center. Go to detail, and let's turn off group mask from a motion to a digital logic, and let's go to end. Now this is a fairly easy code, mainly because when we're looking at robot number 2, is it less than this number right here? And if you don't remember what that number was, it was negative 174. Okay, so if we're less than 174, so let's go new instruction, if statement, and we can do it as a simple if-then statement. So if-then, which allows us to do an else statement. That's why I use the then. So if register number 11, which is our Y position, is less than equal to that negative 174, so that means it's to the left, which is in this area right here, then we're going to send a digital output number 2. Number 2 represents that we are in the middle. IO, digital output number 2, and we're going to set that to on. Now, if we are not past that, then we're going to use the else statement. So let's go to if select, move over, and go else. So else would be digital logic number 2 is going to be off. So that means we are not inside there. So as soon as we move over that 174, that negative 174, then that number 2 output goes on. If we are to the right of that, it's going to be off. Now we need to end that if statement. End if. There we go. So now, if you notice, we don't have a label. Now the reason why we don't have that is because we're running this as a background logic. Background logic means it runs through the program every 8 milliseconds. So let's go to that background logic area. So let's go to menu, setup, background logic, and let's go to number 2, and we're going to go choice, and here's my in the middle, and we're going to run it. So now this is running with the position monitoring as well. Every 8 milliseconds this is running. So now if I go back to select, everything is now set up for robot number 2. All we need to do is do the same thing for robot number 1 and just change some of the numbers. Now we can do this really easily by sending the program over to robot number 1. So let's do that. So let's go to robot number 2. Let's find the send over to robot, right click on it, export to robot, and let's go to the right icon here, and then we need to find that cell. And then we're going to send it to robot number 1. So we select, and then we hit export. It'll establish the FTP, which is File Transfer Protocol, and we're going to hit done. Okay, so now that is sent over. Let's do the same thing for the in the center. So let's click the in the center, right click, export to robot, and this path is all good, so we just go export. Done, and now we have that for our robot number 1. So let's go under robot number 1, and let's go to send over to robot. This switches controllers from robot controller number 2 to robot controller number 1. Let's go into that program, send to, and all we have to do is reset up these numbers. So if you remember here, this is going to be negative 473, 950, and then 176, and then 408 for the other side. So let's go inside here and set this all up. Then all these other items are going to be the same. Nothing's going to change on that. Okay, so now let's go to that circle program, and let's add that line of code so we're running. So we're going to arrow over, instruction, and we're going to next, multiple control, run, and we are running the send of a robot. Then we need to send that background logic. So let's go menu, setup, background logic, number 2, because again, these are 2 different controllers, so you have to set them up on both controllers. Choice, there is our in the center, which we do have to change, so let's change that first. So let's go select and find that in the center, and that center is going to be 176. 176. Now we need to change this before we turn it on, because as soon as we turn it on, it's going to give us an error here if we try to change this. So let's go back to that background logic, and now we can run this. So if we go running, now if you ever need to change these programs, you do have to stop that status. So just hit stop, and then you can change it, and then just go back and run it again. If you want to get rid of it, just hit clear. So stop and then clear. So let's now check everything out to make sure everything is good. Circle example number 1. Everything run. We have our center portion. We have our stop motions. Let's set up the run command here. So cycle start. So let's go to run configuration, and I'm going to go down to number 4, and I'm going to go to RoboGuide user defined, and we're going to run our circle example on robot controller number 1, circle example on controller 2, and we'll just call this circle. Hit apply and OK. Let's run this. So let's arrow down to circle, and then let's see if this works. Okay, so I see what's happening now. So I think we got the symbols mixed up here. So when it goes in here, it actually runs past there. So what we need to do is, if we are greater than equal to, so when we stop this, and then let's go into menu, let's turn the teach pendant on, setup, background logic, let's stop this so we can change this, go to select, and then let's find that program in the middle. And here's that less than. So we don't want the less than, we want greater than equal to. So to the right of this. So let's go choice, and then greater than equal to. There we go. So now let's go back to the background logic. Go to setup, background logic. Let's run this. Go back to the program here. And I'm going to stop. I'm going to run the home position to bring it back to home. And then let's run the circle program again, and this time it should work. So notice how it holds until it gets out of that position, moves in. We are in the blue area, so that's going to come to controlled. Let's hold. This is holding. So you can see everything is working perfect. So it doesn't come to immediate stop, remember, because it is a controlled hold. Complete stop is bad for the robot, or not as good to the robot as a controlled hold. There we go, and we're running the end. So that is running with a little bit better code in our unsafe area. Now again, keep in mind that we are pushing the limits of both of these robots being in the same position over and over again. Circle, circle, circle. Most likely you're not going to have this scenario where you have 2 robots going in at the same time and the same program over and over and over again. So writing code that will help determine whether you're in that safe position or not in that safe position definitely helps. And you can utilize the digital ins and digital outs to help that.